So, hello students, I am Mohammad Saib. I have completed my B.Tech from Kennedy Sultanpur in 2015, and I am the mentor of thousands of students pursuing their B.Tech and MBBS in different reputed colleges of India. I have worked in many reputed institutes like Akash Institute, Vidya Mandir classes, physics wala, and currently now I am working in gravity classes. So today I am going to discuss a topic, projectile motion. Very simple topic. It is a very simple topic, projectile motion. So let us see. Projectile motion. So you have all aware about the whenever you throw a ball obliquely, or whenever you throw a ball to your friend, the motion of the ball is a parabolic motion. Actually this follow the path of parabolic path, and motion of the particle is called projectile motion. In a game of football, then the motion of the ball is the example of projectile motion. So you can define the projectile motion like that. Whenever you throw a ball obliquely near to the earth's surface, the motion of the ball is called projectile motion, and the path followed by the particle is a parabolic path. We will prove the path of the projectile is a parabolic. So it is an example of two-dimensional motion. So how to analyze the projectile motion? Because we know this is the example of motion in a plane or motion in two dimension. So how to analyze motion in two dimensional? So whenever we analyze the motion of a particle in a planes, we have to resolve all the parameters like acceleration, velocity, position in two perpendicular direction. Because what is the motion in a plane, what is the motion in two dimensional? It is nothing but it is the combination of two perpendicular simultaneous straight line motion. So whenever we analyze the motion in two dimensional or motion in a plane, we have to resolve all the parameters like velocity, acceleration and position in two perpendicular direction. So the two perpendicular direction, we assume the two coordinate axes, one is x axis and other is y axis. So let us see how we analyze the projectile motion. As we know, the definition of projectile motion is that whenever you throw a particle obliquely near to the earth, its motion is called projectile motion. So let us consider an object which is thrown from here. Consider the two perpendicular axes. Here the two perpendicular axes, we have to select. One is horizontal axis called x axis and the other is perpendicular axis called y axis. So let us suppose this is your x axis and this is your y axis. The perpendicular direction show the y axis. Suppose a particle is thrown from this point obliquely, means making an angle theta from the horizontal, that is the x axis. So the path followed by the particle will be like that. Like that. This is your horizontal axis. So here is the initial velocity of the particle u, and this is the angle of projection, angle made by the initial velocity of the particle with the x axis with the horizontal is called angle of projection. This is here theta. So as we said, we have to analyze the motion in a plane, we have to resolve all the component in two perpendicular direction. Here the component, here the parameters are initial velocity u and acceleration. Here acceleration is acceleration due to gravity only. There is no acceleration other than gravitational acceleration, and gravitational acceleration always work vertically downward in vertical direction, here in y direction. So the acceleration here is downward direction, or it is along the y-axis, that is up ay. We use proper sign convention, so we have to write minus g. And near to the earth's surface, the value of g is 9.8, but for to make calculation simple, we take the value of g 10 meter per second square. Otherwise, it is 9.8 meter per second square. For make calculation simple, we can take it 10 meter per second square. Okay. So let us start. So we have to resolve the velocity u in horizontal direction along x-axis, that is ux is equal to u cos theta, and in the perpendicular direction u by it will be u sin theta. Okay. So here, to analyze motion of the projectile motion, we have resolved the initial velocity along x-axis and along y-axis, and acceleration which is along y-axis only. Acceleration along the, here we have two axes, x and y. So initial velocity along x-axis, is u cos theta, and initial velocity along y-axis is u sin theta. What is the acceleration along x-axis? Acceleration along the x-axis, ax is equal to 0. And what is the acceleration along the y-axis? A by, that is equal to minus g. So if we want to find out position of a particle at time t, so we have to we have to find out the velocity at time t. So what we do? So we have to do, suppose we want to find out velocity vx, because in x direction there is no acceleration, so the velocity along x-axis remain constant. So vx always will be equal to ux, that is u cos theta is equal to constant. And if we want to find out velocity at time t along y-axis, so it will be is equal to v by, we have to use first equation of motion, vy is equal to u by and plus a by into t. So what will be the value of v by? U by, that is equal to u sin theta and minus gt. Suppose at time t the particle is here, so the velocity will be along this direction. So it has two components. One is the vx, which always remain constant, that is u cos theta, and the vertical component vy will be is equal to u sin theta minus. So if we want to find out the magnitude of the velocity v at time t, so we have to write v is equal to vx I cap plus v by j cap. So what is the value of vx? That is u cos theta. And what is the value of vy? That is equal to u sin theta minus gt j cap. So this is the velocity of the particle at time t. Suppose the particle at time t is making an angle alpha with the horizontal. This is the alpha. So how to find out the value of alpha? Simple, tan alpha is equal to tan alpha this side upon perpendicular upon base. Perpendicular is vy and base is vx. So you can put, or otherwise you can take tan alpha is equal to coefficient of j divided by coefficient of I, that is equal to u sin theta minus gt divided by u cos theta. So you can find out the value of alpha, that is the direction of velocity with the horizontal, what angle the velocity is making with the horizontal. So this is the angle alpha. And if we want to find out the position of the particle at time t, so how do you find the position of the particle at time t? So here is the two coordinate. One is the x, this is the value of x, and this is the value of y. So we have to find out x-axis, we have to analyze motion along x-axis, and to find out the y, we have to analyze motion along y-axis. These are the two perpendicular straight line motion. So if we are analyze motion of the particle along x-axis, we don't require any attention of y-axis, because all the component acting along y-axis does not affect the value which is acting along x-axis. Both the motion are independent to each other. The parameters along x-axis does not affect parameter along y-axis, and similarly parameters along the y-axis does not affect parameters along x-axis. So these are the two independent motion of x and motion along y-axis. These are the two perpendicular straight line motion, and they are independent from each other. Only the common thing between the two perpendicular straight line motion is the time. Other thing, velocity of x-axis does not affect the velocity of y-axis, and the velocity of y-axis does not affect velocity of along x-axis. Similarly, the acceleration of y-axis does not affect acceleration or the motion along x-axis. And we can say all the components are different from each other. Component of x-axis does not affect on y-axis, and y-axis component does not affect on x-axis. So here we have to find out the position of the particle at time t. So find out the value of x and value of y. So as we know, the motion along x-axis is a uniform motion because there is no acceleration. So the value of x at any time, it will be is equal to ux into t. And to find out the value of y, so y is equal to, let us use the second equation of motion, that is equal to u by into t minus plus half a by into t square. So put the value of u by, what is the value of u by? That is equal to u sin theta into t minus, because value of a by is equal to minus g, so it will be is equal to half g t square. So this is the value of y. So if we find out the position of the particle at time t, so what is the value? This is the position, this is the r. So what is the value of r? R will be is equal to x I cap and by j cap, and we have calculated the value of x and y. Here is the value of y and here is the value of x. And if we want to find out the trajectory of the particle, as we have said, the trajectory of the projectile motion is a parabolic. So let us see the equation of the path of the projectile. So what is the trajectory? Trajectory is the mathematical equation of the path followed by the particle. So, or you can say it is the relation between x and y. If a particle is moving on a plane, so it is the relation between x and y. So here we know x is equal to is ux into t, and here y is equal to u sin theta t minus half gt square. We have two equations in x and y, and t is the common thing between the two equations. So from these two equations, if we are able to eliminate the value of t, we can find out the equation of trajectory. So here the value of t is equal to x upon u sin theta. Okay, so let us see the different page. Equation of trajectory. Equation of trajectory. So we know x is equal to u cos theta into t, and from here the value of t comes out x upon u cos theta. And what is the value of y? Y is equal to is u sin theta into t minus half gt square. So put the value of t in equation second. So what will be the value of y? U sin theta, and the value of t is x upon u cos theta minus half g x upon u cos theta whole square. So the value of y is the u will be cancelled out from each other. It is equal to x tan theta minus gx square upon 2u square cos square theta. So this is the quadratic equation in x. Any quadratic equation represent a parabola. So the path followed by the projectile motion is a parabola. So, and now we are going to discuss different parameters related to the projectile motion, that is the what will be the time of flight, what will be the maximum height achieved by the particle, and what will be the range of the particle. So we discuss in the next lecture. Thank you.